Before we jump into the assertion, it is essential to comprehend what molecular accelerators are. The Large Hadron Collider, LHC, operated by CERN, is a 17-meter ring of superconducting magnets. It is the world's largest and most powerful particle smasher. It represents the pinnacle of human scientific achievement. In fact, it is so powerful that it can reproduce the conditions of the universe's earliest moments. Yet, might this machine open the secrets of the universe or hold the key to something significantly more profound? Established in 1954, CERN is one of the world's most renowned research organizations. With 23 member states and countless scientists, it serves as a hub for collaboration and innovation. The LHC is CERN's central project, yet it is only one part of a vast network of particle accelerators and experiments. Picture a racetrack, not for cars or people, but for subatomic particles, in a test of skill, patience, and even space itself. The LHC speeds up protons to nearly the speed of light, sending them on a collision course that replicates the energy of the universe at the moment of the Big Bang. The impacts of these collisions produce temperatures many times hotter than the core of the Sun. A variety of magnets guide the protons on their journey, while advanced cooling systems keep the magnets colder than outer space. Inside the LHC, the beams are made to collide at 4 points around the accelerator ring, corresponding to 4 particle detectors: Atlas, CMS, ALICE, and LHCb. Each detector serves a unique purpose, exploring different aspects of particle physics. Together they act as massive cameras, capturing images of these collisions. Scientists then sift through the debris, searching for traces of the elusive Higgs boson, also known as the God particle, and other phenomena that offer clues about the universe's fundamental building blocks. By focusing on the microcosm, we gain insights into the universe. However, with each answer comes a new question, and with each discovery, new experiments arise. The LHC isn't just a scientific tool, it is a testament to human curiosity and progress. It embodies our relentless quest to understand the universe and uncover the fundamental forces that shape it. Yet, as we push the boundaries of what we know, we must also consider the deeper and existential questions that arise. What are the risks of delving into the unknown? Could our quest for understanding inadvertently unleash forces we cannot control? In the hallowed halls of CERN, where the limits of human comprehension are continually stretched, a discovery has emerged that sends chills down the spines of even the most prepared scientists. Brian Cox, a former researcher at CERN and a prominent voice in the field of particle physics, has recently made a statement that has captivated and unsettled the world. Cox's words resonate with chilling clarity. The goal of CERN's Large Hadron Collider is to recreate a miniature Big Bang. Yes, you heard that right, a small-scale version of the very event that birthed our universe. Cox also explained the implications of this objective, emphasizing the LHC's remarkable potential to make new discoveries. These include unlocking the secrets of the Higgs boson and exploring dark matter, a mysterious substance that makes up a significant portion of the universe. Imagine grasping the power of creation, the ability to summon the very essence of the universe. It's an enticing possibility, but one fraught with risk. The miniature Big Bang isn't a theoretical concept. It's a tangible reality. Within the LHC, the temperatures, pressures, and raw energy replicate the conditions at the universe's birth. It's like standing at the dawn of recorded history, witnessing the birth of existence itself. However, with such power comes responsibility, and the question looms: what if something goes wrong? In fact, something did go wrong back in 1978. Russian physicist Anatoly Bugorsky experienced an accident that would forever change the course of his life. While working on the UB-70 synchrotron at the Institute for High-Energy Physics in Protvino, Russia, a malfunction caused a proton beam to pass directly through his skull. The beam, with an energy that defies comprehension, entered the back of his head and exited through his nose. Bugorsky's experience was extreme. He saw a flash brighter than 1,000 suns yet felt no immediate pain. The beam's path caused severe damage, burning tissue and bone, but Bugorsky remained conscious and even walked to the medical center for treatment. The outcome was both alarming and fascinating. The beam's path caused localized tissue damage, leading to hearing loss in one ear and partial facial paralysis. Remarkably, however, his intellectual faculties remained intact, and he continued his scientific career. This incident is not an isolated tragedy. It serves as a reminder of the immense power and potential dangers of particle accelerators. The risks of a particle smasher like the LHC are not to be taken lightly. The possibility of terrifying reactions and alterations to the very fabric of existence are real concerns voiced by some respected scientists. Perhaps the most troubling and intriguing concern related to the LHC's experiments is the possibility of creating a miniature black hole. Black holes are regions of spacetime where gravity is so strong that not even light can escape. They are massive vacuum cleaners, devourers of stars, and mysterious entities lurking in the shadows of the universe. The idea that the LHC could potentially create such an entity, even on a brief scale, is staggering to both the public and scientists alike. Could this black hole grow uncontrollably, consuming the Earth from within? Scientists at CERN have assured the public that any black hole created would be unstable and dissipate quickly. However, the remote possibility has sparked discussions, fears, and a sense of awe at the power we wield. To understand how the LHC could create a black hole, it is vital to look at the fundamental mechanics of particle accelerators. When protons are smashed together at nearly the speed of light, the energy released is so immense that it warps the fabric of spacetime itself. Imagine a trampoline stretched tight, with a heavy object dropped onto it. The fabric bends, and if the object is heavy enough, it could create a depression so deep that nearby objects are pulled into it. This analogy explains what could happen at the LHC. In the realm of quantum physics, where the laws of the universe are bizarre and wondrous, there exists a theory that extra dimensions may be hidden within our universe. If these dimensions exist, the LHC's experiments could tap into them, creating a gravitational well that forms a small black hole. This enigmatic dance of particles has even drawn the attention of several prominent experts, including the late Stephen Hawking. In his book, Hawking warned of a scenario where the Higgs boson could become unstable at very high energy levels. This instability could lead to a catastrophic vacuum decay, a destructive event that wouldn't just obliterate the Earth but could potentially annihilate the entire universe. The esteemed British cosmologist and astrophysicist Sir Martin Rees also expressed concerns about the experiments conducted at CERN. In his book on the future, Prospects for Humanity, Rees discussed the potential risks of atom smasher experiments, including those at CERN. His words weren't cautious. They were tinged with a sense of existential dread. He explored the worst-case scenario, where a failed experiment could create a condition called vacuum instability. Shakiness could hypothetically set off a stage change resounding through the texture of spacetime, causing a disastrous occasion that could immerse the whole universe. He recognized that such results had a low likelihood, yet he contended that even a small chance warrants serious thought. The stakes are unbelievably high, and the edge for mistake is razor-thin. The specialists at CERN have run simulations, analyzed hypotheses, and taken precautions to ensure the safety of the LHC. In fact, Brian Cox himself acknowledged the importance of these measures, recognizing the widespread concerns surrounding the LHC's activities. Cox stressed that there are rigorous safety protocols in place. Thorough reviews ensure that the LHC's operations are conducted with extreme care. Cox reassured the public that the energies involved are well within the natural limits of Earth's environment, and that the chances of creating a stable black hole are cosmically low. Even if one were created, scientists state it would be so minuscule and unstable that it would disintegrate rapidly in an explosion of energy, a phenomenon predicted by Stephen Hawking, known as Hawking radiation. It would be a fleeting moment of cosmic wonder, just a brief glimpse into the abyss before vanishing. Some have speculated further, suggesting that the LHC's experiments could open a doorway to another universe or dimension. While this idea is largely dismissed by mainstream scientists, it has captured the imagination of many, becoming a subject of intrigue, fear, and even legend. What lies beyond our universe? Could we accidentally unleash forces or substances that we do not understand? The notion of opening a doorway to hell has even been dramatized in various media, stirring up uncertainty. But how did this idea arise, and what does it mean in terms of scientific exploration? The concept of extra dimensions is not new in physics. String theory, a leading contender for a unified theory of everything, suggests that there may be more than the usual 3 dimensions of space and 1 of time. These extra dimensions could be compactified, hidden from our perception, yet theoretically accessible or revealed under extreme conditions. Now, imagine the LHC as a cosmic key, unlocking doors that have been sealed since the dawn of recorded history. When protons collide at energies never before achieved on Earth, they could, in theory, create ripples or waves that probe these hidden dimensions. If these dimensions exist, the LHC could potentially reveal them. Yet, before we get carried away with wild speculation, it's important to note that while the LHC is immensely powerful, there is no definitive evidence to suggest it will open a door to another universe, let alone to hell itself. Nevertheless, the allure of the unknown, combined with the enigmatic nature of quantum physics, ensures that such ideas will continue to captivate the public imagination. So, should we be worried about the LHC and its potential dangers? It's easy to be swept away by sensational headlines and fears of global catastrophe, but the reality is that the scientists at CERN are acutely aware of the risks involved. They have taken precautions to ensure their experiments are safe and continue to monitor and assess their work with the highest level of diligence. The potential benefits of the research, breakthroughs in our understanding of the universe, the discovery of new particles, and the exploration of dark matter, are truly extraordinary. It's not only a testament to human ingenuity but also a window into the very heart of the cosmos. However, like any great leap forward in science, it comes with its share of risks, and we should approach it with a balance of wonder, respect, and caution. The Large Hadron Collider represents the frontier of scientific inquiry, where theoretical physics meets experimental reality. Its true potential, to answer fundamental questions about the universe, such as the origins of mass and the nature of dark matter, is unparalleled. Despite thorough safety measures and detailed calculations, the LHC still evokes a sense of mystery and fear among some. The sheer scale of the machine and the energy it generates are awe-inspiring, and each new experiment opens the door to uncharted scientific territories. While most scientists remain confident in the safety of the LHC's experiments, there are undeniable uncertainties. What if new, unexpected anomalies emerge that challenge our understanding of physics and the laws of the universe? The LHC pushes the boundaries of human knowledge and tests the limits of our control over the natural world. As particle collisions replicate conditions unseen since the Big Bang, the significance of these experiments raises existential questions about the potential consequences of altering the very fabric of the universe. Regardless, the LHC's achievements in particle physics have been groundbreaking. It has led to the discovery of the Higgs boson, advanced our understanding of the Standard Model, and opened pathways to potential breakthroughs that may one day shape our technological future. Despite the risks, the pursuit of knowledge remains one of humanity's most ambitious endeavors. The journey of scientific discovery is rarely without risk, and the LHC is no exception. Its experiments delve into realms of physics where intuition no longer applies. For decades, physicists have sought to understand the fundamental forces of nature: gravity, electromagnetism, the weak nuclear force, and the strong nuclear force, each playing a critical role in the formation of matter. The Large Hadron Collider is undoubtedly one of the most ambitious scientific instruments ever created, serving as a monumental step in our quest to understand the fundamental nature of the universe. Its experiments push the boundaries of knowledge, delving into realms where the very laws of physics are tested to their limits. By accelerating protons to near-light speeds and colliding them, the LHC replicates the conditions present in the early universe, fractions of a second after the Big Bang. This quest for knowledge, while inspiring, comes with a set of questions, concerns, and philosophical implications that go beyond mere scientific curiosity. Despite the advances made in particle physics, the fundamental question remains: what exactly is the ultimate fate of the experiments being conducted within the LHC? Although scientists have run simulations and accounted for every possible scenario, the unexpected is always a possibility. There could be a new particle interaction or discovery that defies our current understanding, driving physics into uncharted territories. For instance, the detection of dark matter and dark energy could revolutionize our understanding of the universe, leading to breakthroughs we cannot yet predict. Another key aspect of the LHC's impact lies in the potential technologies that could emerge from its research. Particle accelerators have long been a source of innovation, contributing to advancements in medical imaging, cancer treatment, and material science. The LHC is no exception. Beyond its contributions to theoretical physics, it has spurred developments in computing, high-precision instrumentation, and other fields, demonstrating that scientific endeavors often have applications far beyond their immediate goals. This aspect of the LHC highlights the ripple effect that cutting-edge research can have on society, driving innovation in unexpected ways. Nevertheless, the LHC is not immune to scrutiny. Critics, including some prominent scientists, have raised concerns about the direction of such high-stakes experiments. What if, in the pursuit of answers, we accidentally unleash a phenomenon that we are ill-prepared to understand or control? Hypothetical concepts like quantum fluctuations or the creation of black holes, though highly unlikely, invite discussions on the responsibility inherent in wielding such immense power. These fears, though largely speculative, resonate because they tap into a fundamental fear of the unknown, a fear of going too far and discovering something that cannot be undone. In reality, the scientific community has taken an extremely cautious approach to mitigate risks. Researchers regularly reassess the potential dangers of their experiments and are committed to rigorous safety protocols. Many of the perceived risks, such as the creation of a stable black hole, are practically non-existent based on current understanding. Still, the questions raised by the LHC's research highlight the delicate balance between progress and caution in science. While the rewards could be transformative, so too could the consequences, should something unforeseen occur. As the LHC continues to operate, it serves as a reminder of the boundless curiosity that drives humanity's quest for knowledge. Despite the uncertainties and fears surrounding its work, the desire to understand the universe remains at the heart of this global scientific endeavor. The LHC's mission, whether it leads to answers about dark matter, the Higgs boson, or even the fundamental nature of reality itself, will continue to shape our view of the universe and perhaps our place within it.